The prevailing thought in sparrow mating is that they are considered as socially monogamous. This means that a brood usually involves a male and a female, and they stay together for the breeding attempt, sometimes even longer, for the whole breeding season or even between years. The Lundy Island experiment is a long-running study that involves multiple researchers, and it's a tiny island in the Bristol Channel, 19 kilometers off the coast of Devon, and that's too far for idle sparrows to fly to the mainland and vice versa, and that makes it perfect for us because we've been monitoring them since 2000, so 17 years now, and we know the precise age of individuals, weight, beak measurements, plumage characteristics, more importantly, how many chicks did they have, with whom did they have chicks or never had chicks, etc. And in that sense, Lundy Island for us, it's like a natural big brother house sparrow laboratory. Through genetic testing, what we mean by genetic testing is DNA fingerprinting for paternity analysis. So we take DNA samples of the chicks, and then we also catch the female and the male attending the nest, take a DNA sample of those, and see if they match. So if those adults are indeed the genetic parents of those chicks. And what we found is that true monogamy is very rare in birds. So it seems that almost all of the bird species are genetically promiscuous. We would love to know how frequently extra-pair couple mating occurs, but it's super hard to observe. So we only have a proxy, and the proxy is extra-pair offspring, and they occur at a rate of 34%. That means that 1/3 of all the broods contain at least one extra-pair offspring. So surprisingly, they actually do worse than offspring from within the pair. And what we mean by worse is that they have a lower chance of surviving into adulthood. And it's surprising because the expectation go against, so you would expect them to be of higher quality compared to within-pair offspring. So the implication of this extra mating, it's best to look at the female and the male separately. For the male, it's straightforward. He's not limited in his sperm, or not so limited. And every extra pair mating can result in an extra pair offspring, so that's adaptive. There's a great advantage there. For a female, it's more puzzling why she does it, because she cannot increase the number of eggs. So it must be something about the quality of this partner that she goes off with. And it could be, there are hypotheses that predict that if she is paired to somebody of lower quality, let's say an infertile partner or genetically related to her, she's more likely to engage in these extra pair mating scenarios. But there is no good evidence for that. Instead, what was found in zebra finches, for instance, is that promiscuity itself is a shared component, a genetically shared component between males and females. So if a male cheats, a female is more likely to cheat, and if it's beneficial for the male, it will be selected for, and then automatically it can be selected for in the female too. This whole adaptive thinking for females is, we don't need these explanations, just because it still increases reproductive success in males. Males and females share the genetic base for that behavior, the behavior of promiscuity. It also gets selected for in females, and that would be called like a correlated evolutionary response, indirect selection in females because of reproductive advantages in males.